Good morning, friends. Today I am presenting a research findings of our work on rainfall variability analysis and change in the northern mountainous region of India. The outline of our presentation will be like this. We will talk about the methodology. We will talk about weather stations in northern mountainous region. And we will also talk about how we have analyzed the rainfall variability and change in the western Himalayan region. And finally, we will talk about conclusion. So, we have collected data of rainfall from 1846 to 2006. It is almost 160 years from the Indian Institute of Tropical Meteorology, Pune, Maharashtra. And as the Western Himalayan region is comprised by three states, Uttarakhand, Himachal Pradesh, and Jammu and Kashmir. So we have collected the data from these three states. The data were analyzed as the monthly average of rainfall, the annual average of rainfall, decadal average of rainfall, and season-wise annual and decadal average of rainfall. So this map, you can see that this is the location map of the three states of the Western Himalayan region. The Jammu and Kashmir, the Himachal Pradesh, and Uttarakhand. And you can see here in these three states, there are weather stations. So highest weather stations are located in Himachal Pradesh, more than 12, followed by Jammu Kashmir and Leh Ladakh region. They are about 10 stations, and then the Uttarakhand Himalaya finally, where the weather stations are comparatively less than the other two states. So you can see this graph. So about 160 years data we have analyzed, and we got the linear regression of this data. And we noticed that the annual average rainfall is highly variable during this period. Minimum from 900, 800 millimeter to more than 3000 millimeter rainfall. And then this variation is within these two, limits. And then if we see average rainfall change during the 150 years, so we find that it is quite decreasing. The Western Himalayan region, the rainfall is decreasing, and the R square value is 0.001%. So this decreasing rainfall is also one of the important issue that we will talk about. So also the season-wise variation of rainfall in these three states we have analyzed. The first 3 months, January, February, and March. These months are actually called for the precipitation from the western disturbances. But now the trend is decreasing with high variability. This the graph number 1, you can see. And definitely there is a decrease in the rain precipitation, while this is the time for the precipitation from western disturbances. And we have noticed this year also. So far, this is the month of January, only one small spell of the rain and snow was taken place, but there is no rain, no snow. The second B graph shows the 3 months, April, May, and June. This is the dry month for the Western Himalayan regions, but you see that the rainfall is increasing. So this is again a different pattern coming up with very high, that variability. Maximum rainfall is more than 4,000 millimeter, and minimum also it is 50. So that during this region variability is high, and but the that rainfall is increasing. Third graph is C graph is during the month for uh, July, August, and September, and these 3 months are meant for the monsoon rain, heavily rainfall in the this part of the Himalaya, but the trend is decreasing, and R square value is 0.020. So there is, that a decrease, large decrease in rainfall during the monsoon. And again, when we look into the graph D, it shows that the rainfall is for October, November, and December. This is for the dry season, except the December, second half of December, when there is rain from the western disturbances. So there is increase. So this is clearly shown that that the month where there was rainfall, now there is no rain. In the months where there was rain, there is no rain. So it is all vice versa, and it is changing like this. So this is decadal seasonal rainfall, and if you see that for the month of January and February, March, it is again decreasing, the graph A. And this is the season, as I told you, the season for precipitation. Again, B, it is for April, May, and June, the B graph, but the rain is increasing. This is also the dry season for the Western Himalaya. It is decadal seasonal rainfall. And again, during the monsoon season, there is decrease in rainfall, and again, the dry season of October, November, December, there is increase. So this is all going very, that adverse, and in contrast, this rainfall patterns are going on. In terms of the decadal average of monthly rainfall, so high rainfall variability is in March, in July, between July and August, and also in December, also in June. So the variability is very, very high, and also it is changing. Sometimes in dry season it is increasing, and in rainy season it is decreasing. So that is one of the important issues to be talked. So we have also analyzed decadal minimum, maximum, and mean value of the rain, and we found that the mean value is decreasing, maximum value also decreasing. On the other hand, the minimum value is increasing. So that is the trend. That is the trend of the rainfall variability and changes. And then, in conclusion, our research findings shows that high variability in rainfall patterns across the western Himalayan region. Average annual rainfall is decreasing. Season-wise variability of rain is very high. Rainfall decreasing in the rainy and winter seasons. It is increasing in October, November, December, and April, May, June. These are the dry seasons. And mean and maximum value of rainfall is decreasing, and minimum value of rainfall is increasing. So these are the trends of, that the rainfall variability. And I thank you very much for this, that listening, and please share this video if it is useful for you. This is based on our, that the research on the Western Himalayan region. And once again, thank you very much.